A spacecraft the size of a basketball court just sent back an image so strange that the scientists who built it stopped what they were doing and stared at their screens in silence. What you are about to hear is not science fiction. It is not a rendering. It is not an artist's impression. It is real data beamed across 600 million kilometers of empty space from a world so massive that every other planet in our solar system could be dropped inside it with room to spare. Before I tell you what NASA found, hit that subscribe button right now, because what comes next will change the way you think about the giant orange ball floating in your night sky. Stay until the end, because the final discovery on this list is the one that has planetary scientists quietly admitting they don't fully understand the planet they've been studying for 50 years. Let's start with the basics, because you need to understand just how insane this mission actually is. In August of 2011, NASA launched a solar P-powered spacecraft called Juno from Cape Canaveral, Florida. Think about that phrase for a second. Solar-powered. Jupiter sits so far from the Sun that sunlight arriving there is roughly 25 times weaker than it is here on Earth. Every other deep space mission that far out relied on nuclear power. Juno was the first to attempt something this ambitious, using nothing but sunlight and 3 massive solar panels stretching out like wings. Engineers said it couldn't be done efficiently. Juno proved them wrong, and it has been proving people wrong ever since. It took 5 years for Juno to reach its destination. Clears throat. On the 4th of July 2016, while most of America was watching fireworks, Juno was performing a nail-biting engine burn to slip into orbit around Jupiter, threading a needle between the planet's crushing radiation belts. One tiny miscalculation and the spacecraft would have been fried instantly by radiation levels strong enough to kill a human in minutes. It worked, and what Juno has sent back since that day has left mission scientists rewriting textbooks again and again. Here's the first shock. Jupiter's magnetic field is not what anyone expected. Every science class teaches that planets have a simple magnetic field like a bar magnet, with one clean North Pole and one clean South Pole similar to Earth's. Juno discovered that Jupiter's magnetic field is nothing like that. Instead of one smooth, simple structure, the field is lumpy, twisted, and asymmetric with multiple magnetic poles tangled together in a chaotic mess that is far more complicated in the northern hemisphere than in the south. Imagine expecting a perfectly smooth balloon and instead finding a balloon covered in random bulges and dents that nobody can explain. That is what scientists are dealing with. This discovery alone forced researchers to reconsider what is happening deep inside the planet. Because a magnetic field this strange suggests that whatever is generating it, likely swirling metallic hydrogen deep in Jupiter's interior, behaves in ways nobody predicted. And that leads directly into the second shock. Juno's radio and gravity measurements revealed that Jupiter's atmosphere is not just a thin layer of colorful clouds sitting on top of the planet like icing on a cake. The turbulent bandit structure you see in every photograph extends downward for hundreds of kilometers far deeper than scientists had modeled. Those famous stripes of orange, white, and brown that wrap around the planet are not a surface feature. They are the visible tip of enormous weather systems that plunge deep into the planet's body, tangled up with the intense internal dynamics of a world that has no solid ground to stand on anywhere. Picture a hurricane on Earth, but instead of dying out after a few weeks, it rages continuously for centuries, reaching down thousands of kilometers below what you can actually see. That is the reality Juno uncovered. Now let's talk about the images themselves, because this is where things get genuinely eerie to look at. Juno carries an instrument called JUNOM, a relatively simple 2-megapixel visible light camera that was originally added almost as a bonus for public engagement rather than as a primary scientific tool. Nobody expected it to become one of the most important instruments on the entire spacecraft. Citizen scientists around the world, ordinary people with no NASA badge and no laboratory, have taken the raw data Juno cam beams home and processed it into images so detailed and so alien-looking that many viewers assume they must be computer-generated art. They are not. They are real photographs of a real planet closer and clearer than humanity has ever seen it. One image processed from Juno's 66th close flyby of Jupiter shows the planet's turbulent atmosphere in such fine detail that you can trace individual storm cells swirling into each other like cream being poured into black coffee. During that same flyby, Juno also swept past Amla, one of Jupiter's smaller inner moons, a reddish potato-shaped rock roughly 160 kilometers across, tumbling through one of the most radiation-soaked regions in the entire solar system. Mission scientists have compared studying Jupiter to reading an ancient inscription that holds the secrets of how our entire solar system came to be, because so much of the raw material left over from the birth of the Sun got swept up into this one gigantic planet. But perhaps nothing captures the sheer alien strangeness of this mission better than what Juno has revealed about Jupiter's poles. Before Juno, no spacecraft had ever managed to look directly down at Jupiter's north and south poles. Every previous mission approached from angles that only showed the familiar striped equatorial view. When Juno finally tilted its orbit and looked straight down, scientists were not prepared for what they saw. Instead of the calm, orderly bands you see everywhere else on the planet, both poles are covered in dense clusters of gigantic cyclones, swirling storms as wide as entire continents, packed together in strange geometric patterns like something out of a fever dream. The North Pole alone contains a cluster of 8 massive cyclones arranged around one central storm, locked in a stable formation that has persisted for years without merging or drifting apart, defying the normal behavior fluid dynamics would predict. Nobody has been able to fully explain why these storms remain in such a rigid, almost engineered-looking pattern instead of colliding and destroying each other the way similar storms would on Earth. Now, let's move to the moons, because this is where the mission has produced some of its most jaw-dropping and frankly unsettling footage. Jupiter has more than 90 known moons, but 4 of them called the Galilean moons because Galileo Galilei discovered them centuries ago dominate the story. Io, Europa, Ganymede, and Callisto are each worlds unto themselves, and Juno has visited close enough to some of them to fundamentally rewrite what we thought we knew. Start with Io. This moon is the most volcanically active body anywhere in the entire solar system. More active than Earth, more active than anywhere else humans have ever observed. Its surface is a nightmarish landscape of sulfur-colored plains, constantly resurfaced by lava flows that erupt from hundreds of active volcanoes. During a series of extremely close flybys conducted in late 2023 and early 2024, Juno swept as near as roughly 1,500 kilometers from Io's surface, close enough to capture direct images of glowing lava lakes and active volcanic plumes rising above the horizon. One image showed what researchers now believe was the largest volcanic eruption ever directly observed on Io. A fountain of molten rock so intense that it was detected purely from its thermal glow, using an instrument that was never even designed to be a camera in the traditional sense. That instrument is called the Stellar Reference Unit, or SRU, and its story is almost as remarkable as what it captured. The SRU exists purely for navigation. Its job is to look at star fields so the spacecraft's computer can figure out exactly which direction it is pointing. It was never built to take pictures of planetary surfaces, but because it is extremely sensitive in low light conditions, engineers realized they could repurpose it to capture Io's night side, when the moon is bathed in darkness except for the glow of its own volcanoes. The resulting images show a black star scattered background punctuated by pinpricks of orange and white light scattered across Io's surface. An entire moon lit up not by sunlight but by its own internal fire. Looking at that image, knowing every glowing dot is an active volcanic eruption happening on another world right now, is one of the most quietly terrifying things modern astronomy has produced. Then there is Europa, the icy moon that has become the single most talked about target in the entire search for life beyond Earth. In 2022, Juno flew within roughly 360 kilometers of Europa's surface, using a microwave radiometer to peer beneath the ice and measure the thickness of the frozen shell covering the moon. The data suggested an ice shell roughly 18 miles thick, sitting on top of what scientists strongly believe is a vast salty liquid ocean, potentially containing more water than every ocean on Earth combined. Here's the unsettling part. A shell that thick means whatever is happening in that ocean, any chemistry, any potential biology is sealed away under miles of solid ice, hidden from direct observation, protected from radiation, and kept in a stable, dark environment, not unlike the deep ocean trenches on Earth, where life thrives without a single ray of sunlight. Scientists have openly said that this thickness could actually work against the odds of detecting life from orbit, because anything living down there is buried under a fortress of ice with almost no way for evidence to reach the surface. And then more recently, in May of 2026, Juno made an extremely close approach to a smaller, far less famous moon called Thebe, the second largest of Jupiter's inner moons. Flying within roughly 3,100 meters of Thebe using the same stellar reference unit that captured Io's volcanoes, Juno photographed the moon in detail. Nobody had ever achieved before at a resolution of about 1.9 meters per pixel. Thebes sits at the outer edge of Jupiter's faint, dusty ring system. And mission scientists now believe this small, irregular moon is directly responsible for feeding one of Jupiter's rings, known as the Gosma ring, by constantly shedding fine dust particles from impacts on its surface. In other words, this obscure little moon that almost nobody has heard of is quietly manufacturing part of a planetary ring system in real time right now as you listen to this. Here's something else that will surprise you. Juno's camera almost didn't survive long enough to capture any of this. By the time the spacecraft reached its 56th orbit around Jupiter, Juno Cam had absorbed so much radiation that its images started coming back covered in static noise and grainy distortion. The digital equivalent of a camera sensor slowly dying. Engineers back on Earth, facing what looked like the end of one of the mission's most beloved instruments, tried something almost nobody expected to work. They subjected the damaged camera to a process called annealing, deliberately heating the sensor to a specific temperature to allow its internal structure to repair itself at a molecular level. It should not have worked as well as it did. On the very next orbit, Orbit 57, Juno came back to life, producing images nearly as sharp as the day it launched, allowing it to capture even more detailed views of Io's active volcanism afterward. A spacecraft literally healing its own camera hundreds of millions of kilometers from the nearest repair technician sounds like something out of a movie, but it happened, and it is one of the quieter miracles of this entire mission. Let's talk about scale for a moment, because I don't think most people fully grasp just how enormous the subject of these photographs actually is. Jupiter is so large that more than 1,300 Earths could fit inside it. Its great red spot, a storm that has been raging for at least the last 150 years and possibly far longer, is itself larger than the entire planet Earth. Even though recent measurements from Juno show it has actually been shrinking and changing shape in ways researchers are still working to fully understand. Juno's instruments have probed beneath that storm and found that its roots plunge at least 200 miles down into Jupiter's atmosphere, far deeper than the visible red cloud tops suggest. Meaning the storm you see in every photograph is only the very top layer of something vastly bigger churning underneath. Now, here's a discovery that genuinely unsettled some members of the science team. Jupiter's interior, according to gravity measurements taken by Juno, as it swings close to the planet during each orbit, does not behave like a simple layered ball the way models assumed for decades. Instead of a small, solid core surrounded by clean layers of metallic and molecular hydrogen, the data suggests the core itself may be diffuse, essentially dissolved and blended into the surrounding layers, rather than sitting as one solid, well-defined ball. Some researchers believe this could be the result of a massive collision early in the solar system's history, a giant impact that effectively scrambled Jupiter's interior structure before it had fully settled into its final form. If that theory holds, it means the planet you're looking at in these images is in a very real sense still carrying physical scars from a violent event that happened over 4.5 billion years ago at the very dawn of our solar system. Think about everything I've just described. A magnetic field that shouldn't exist in the shape it does. Storms deeper than entire countries are wide. Polar cyclones locked in patterns physics can't fully explain. A volcanic moon lit up like a nightmare landscape from its own fire. An ice-covered ocean world that might be sealed shut against discovery by the very ice meant to protect it. A tiny moon quietly building a planetary ring in real time. A camera that healed itself. And a core that might still bear the wounds of an ancient cosmic collision. This is not a planet. This is closer to an entire alien solar system compressed into one object. And Juno has been sending back photographic proof of all of it for a decade. Juno's original mission was supposed to end in 2017. NASA liked what they were seeing so much that the mission has been extended repeatedly, first through 2021, and then further still transforming Juno from a pure atmosphere and interior study into a broader tour of the entire Jovian system, including its rings and its moons. And Juno will not be alone for long. The European Space A's JWST spacecraft, short for Jupiter Icy Moons Explorer, launched in 2023 and is currently on its own long journey outward, expected to arrive at the Jupiter system in 2031, carrying a far higher resolution camera than JunoCam ever had. When it arrives, scientists expect an entirely new wave of images that could make even these current photographs look primitive by comparison. There's a moon I haven't mentioned yet, and honestly, it deserves its own separate video, because what Juno found there broke a rule scientists thought was rock solid. Ganymede is the largest moon in the entire solar system, bigger than the planet Mercury. And until Juno arrived, nobody had captured a close-up image of it in over 2 decades. In 2021, Juno swept past Ganymede and delivered the first detailed pictures of its icy, cratered surface since the Galileo spacecraft photographed it back in the year 2000. What made this flyby genuinely strange was not just the imagery, but what Juno's magnetometer detected while it passed by. Ganymede is the only moon in our entire solar system known to generate its own magnetic field. A field so strong that it actually carves out its own protective bubble inside Jupiter's much larger and more violent magnetic environment. During the flyby, Juno detected signs of magnetic reconnection, a process where Ganymede's magnetic field lines and Jupiter's massive field briefly merge and then violently snap apart, releasing bursts of energy and particles. Picture 2 invisible force fields colliding in the vacuum of space, tearing and reconnecting over and over, releasing energy nobody can see with the naked eye, but that Juno's instruments recorded in exquisite detail. Some researchers believe this interaction could even funnel charged particles down onto Ganymede's surface in ways that produce faint auroras, essentially giving this giant icy moon its own miniature version of the Northern Lights, hidden away from human eyes until robotic instruments arrive to detect it. Then there's Callisto, the outermost of the 4 Galilean moons and in many ways the most overlooked. Its surface is one of the most heavily cratered landscapes anywhere in the solar system. Essentially a frozen fossil record of billions of years of impacts untouched by the resurfacing and volcanic activity that erased so much history on Io and Europa. Scientists have described Callisto almost like a time capsule, a preserved snapshot of what the early solar system's chaotic bombardment period actually looked like, still sitting there in plain sight, waiting for a closer look than any mission has yet provided. Juno's flybys of the inner system have been so dramatic that Callisto sometimes gets left out of the conversation entirely. But future missions, including JWST, are expected to spend far more time studying exactly this kind of ancient, undisturbed terrain. Let's also talk about something that rarely gets mentioned outside of scientific circles, which is just how dangerous it actually is for any spacecraft to operate this close to Jupiter for as long as Juno has. Jupiter's radiation belts are, without exaggeration, the most punishing radiation environment of any planet in our solar system. The intensity is so extreme that engineers built Juno's most sensitive electronics inside a specially designed titanium vault, essentially a half-centimeter thick armored box, just to give the spacecraft's brain any realistic chance of surviving repeated close passes. Even with that protection, mission planners originally predicted Juno's electronics would degrade to failure after roughly 8 close orbits of the planet. Instead, through careful trajectory adjustments that widen certain orbits to reduce radiation exposure, Juno has now completed dozens upon dozens of close flybys, vastly outliving its original radiation budget. Every single image discussed in this video, every glowing volcano on Io, every storm cluster at Jupiter's poles, every detail captured on Thebe exists only because a spacecraft is quietly absorbing lethal levels of radiation orbit after orbit, just so that data can make it back to Earth. It's also worth pausing on how different Juno's approach was compared to earlier Jupiter missions. Spacecraft like Pioneer 10 and 11 in the 1970s and Voyager 1 and 2 shortly after gave humanity its first ever close-up glimpses of Jupiter. But they were fast flybys, gone within days, capturing only a narrow slice of the planet before speeding off toward the outer solar system forever. The Galileo mission in the 1990s and early 2000s stuck around far longer and even dropped an atmospheric probe directly into Jupiter's clouds. But its data was limited by the technology of that era and by a main antenna that failed to fully deploy, crippling its ability to send images home. Juno was designed specifically to fix these weaknesses, orbiting close and repeatedly using modern instruments and benefiting from decades of improved deep space communication. That is precisely why the images in this video look nothing like the grainy, low-resolution photographs from earlier missions. We are quite simply seeing Jupiter for the first time the way it actually looks, not the way outdated technology forced us to imagine it. And here's something that should genuinely give you chills. Everything you've heard in this video represents only a fraction of the data Juno has sent home. The spacecraft's primary science instruments, including its microwave radiometer, its ultraviolet spectrograph, and its energetic particle detector, have generated such an enormous volume of raw information that researchers are still working through years' worth of backlog, still publishing new papers, still finding new anomalies buried in datasets collected orbits and orbits ago. Some of the most surprising discoveries about Jupiter's deep atmosphere, revealed through radio occultation measurements as Juno's signal passes behind the planet, were only fully understood years after the raw data first arrived on Earth. In other words, there is a very real chance that somewhere in NASA's archives right now sits a discovery about Jupiter that nobody has noticed yet, quietly waiting in a server for the right scientist to finally connect the dots. Let's circle back to those rings for a moment, because most people don't even know Jupiter has rings at all. Saturn gets all the attention with its bright, obvious bands, but Jupiter possesses a much fainter, dustier ring system that went completely undetected until the Voyager spacecraft accidentally spotted it back in 1979. Unlike Saturn's rings, which are made largely of ice, Jupiter's rings are built almost entirely from fine, dark dust, constantly replenished by tiny meteoroid impacts striking small inner moons like Thebe, Hamthea, and Meteis. Every time a speck of space debris slams into one of these moons at extreme velocity, it kicks up a spray of microscopic particles that escape the moon's weak gravity and drift into orbit around Jupiter, slowly building and maintaining the ring system in real time. This means Jupiter's rings are not some ancient fixed structure. They are being actively manufactured this very moment, particle by particle, through a continuous process of cosmic collisions happening far above our heads. Juno's recent close imaging of Thebe gave scientists their clearest evidence, yet connecting a specific moon to a specific ring, turning what used to be a theoretical model into something backed by direct observational proof. There's also a bigger, almost philosophical reason scientists care so deeply about every image Juno sends home. And it goes beyond Jupiter itself. Thousands of planets have now been discovered orbiting other stars across our galaxy. and an enormous number of them fall into a category astronomers call gas giants, worlds broadly similar in size and composition to Jupiter. Because those exoplanets sit so far away that we will likely never send a spacecraft to visit them directly within our lifetimes. Jupiter effectively becomes our closest laboratory for understanding how gas giants across the entire universe actually behave. Every strange magnetic field pattern, every atmospheric storm, every clue about the planet's internal structure that Juno uncovers gets folded into models astronomers use to interpret data from planets trillions of miles away that we can only observe as faint dots of light. In a very real sense, every image in this video is helping scientists understand not just one planet, but an entire category of worlds scattered across the Milky Way. I also want to give credit to something that makes this mission genuinely unique compared to almost every other NASA project in history. Most of the breathtaking images you've probably seen online from this mission were not produced by NASA scientists working in a secure laboratory. They were created by ordinary members of the public, hobbyists, amateur astronomers, and self-taught image processors who download raw, unprocessed data directly from NASA's own servers and painstakingly enhance it using their own software in their own free time. NASA deliberately built this openness into the mission from day one, uploading raw JunoCam data publicly and even inviting the public to vote on which regions of Jupiter the camera should photograph during future flybys. That means some of the most stunning, most viral images of Jupiter circulating across the internet today exist because a person sitting at a home computer somewhere on Earth decided to spend their evening turning raw sensor data into art. It is one of the rare instances in modern science where anyone with curiosity and a laptop can directly contribute to humanity's understanding of another planet. And that alone makes this mission worth paying attention to. So why does any of this matter to you sitting wherever you are right now watching this video on a screen? Because every single discovery I just walked you through forces us to confront something uncomfortable. We spent decades assuming we basically understood the largest planet in our solar system. We had models. We had predictions. We had textbooks confidently describing its magnetic field, its interior, its storms. And then one solar-powered spacecraft smaller than a school bus arrived and discovered that almost none of it was quite right.